Now for our next example, we have the square root of 3x minus 2 being equal to 1 plus the square root of x plus 3. And you'll note, as we did in the last problem, that there are two square root expressions in the equation. And you'll also notice that one of the radical terms is isolated on the left-hand side to begin with, which is helpful. So what we'll do is to square both sides of the equation to start off with. And squaring the left-hand side will eliminate that radical, so it becomes then 3x minus 2. Now you want to be very, very careful on the right-hand side, and you remember a while back we talked about the fact that when you square a binomial you get three terms, and squaring this will produce 1 plus 2 times the square root of x plus 3, then plus the quantity x plus 3. Now if you're not certain how that was arrived at, what you want to do is to write down the 1 plus the square root of x plus 3 twice and use the FOIL method to carry out the multiplication. So now what we'll do for our next step is to simplify combined terms on the right hand side, and we will have then, you can see we'll put x in front here, and the 3 plus 1 is 4. Then plus 2 times the square root of x plus 3. Now we still have a radical in the equation, don't we? So what we need to do is to isolate this radical as our next step. And so what we'll do is take the x plus 4 from the right hand side to the left hand side, and that will produce 2x minus 6 being equal then to 2 times the square root of x plus 3. Now we could of course square both sides with the equation in this form, but there will be an advantage in this case to dividing both sides by 2, because the terms on the left hand side both have factors of 2. So this will be our next step then. So we have on the left hand side x minus 3, and on the right hand side the square root of x plus 3. Alright, now that one radical term is again isolated, so what we'll do is square both sides to eliminate that radical term. And on the left hand side, I trust you'll agree, we will end up with x squared minus 6x plus 9. And on the right hand side, x plus 3. We now have a quadratic equation, so we'll make one side 0, and I'm going to bring all of the terms to the left hand side, so we'll have x squared minus 7x plus 6 is equal to 0. And factoring, we have x minus 1 times x minus 6 is equal to 0. And so the possible solutions we have then would be x equal to 1 or x equal to 6. So we'll now next check both of those values back in the original equation to see which ones are valid. Now checking each of the possible solutions back into the original equation, I've written it out ahead of time here to save a bit of time, because I think this process is fairly clear to all of you. And so if we check x equals 1, what I've done is to replace the x with 1 in the original equation. And so simplifying, then we have the square root of 3 times 1 minus 2, which produces then the square root of 3 minus 2, which is square root of 1, which turns out to be 1. And on the right hand side we have 1 plus the square root of 4, or 1 plus 2, which is 3, and you can see that 1 is not equal to 3. So x equals 1 is not a valid solution. And if we check x equals 6, again I've replaced the x with 6 each place it occurs in the equation. And so simplifying, then we have on the left hand side here the square root of 3 times 6, or 18, minus 2, which produces the square root of 16, which is 4. And on the right hand side we have then 1 plus the square root of 9, which is 1 plus 3, or 4. So that solution does check. So we can then say that the official solution to the equation is just the value x equals 6.